Hello everybody, my name is Anthony Freeman and today I'll be teaching you about Pascal's triangle. Pascal's triangle is often used in math and it can be used to do many things, such as finding probability and using the formulas to find how long can you go with the triangle, how many rows you can find of the triangle. Before I tell you about Pascal's triangle, I'll have to show you some history and background on how it came about. First, we're going to start with Omar Khayyam. Omar Khayyam was born May 18th, 1048, in the city of Nashpur, Persia. One of his most impressive works was treatise on demonstrations of problems of algebra, which advanced algebra, which is what we know today as algebra, obviously. Khayyam constructed the solutions of all kinds of cubics by the use of intersecting conic sections. Khayyam also claimed to be the first mathematician to solve every type of cubic equation having a positive root, but he did not recognize negative numbers as coefficients. He also discovered what's known as Pascal's triangle. History and background on Yang Hu. Yang Hu was born about 1238 in Qiantang, Chekiang Province, China, which is current-day Hangzhou. He died around 1298 in China. There's not a lot of information on Yang Hu other than the fact that he wrote multiple outstanding mathematical texts. Yang is famous for his triangle, which is a special triangular arrangement of numbers used in many areas of mathematics. Yang was one of the first to describe its properties. History and background on Pascal. Pascal's full name is Blaise Pascal and lived from June 19th, 1623 to August 19th, 1662 in Clermont-Ferrand, France. He died in Paris, France. In the 1640s, he created the Pascaline, an early version of the calculator. He was mainly known for his body of notes that were released as the Pieces. Although the triangle had been around long before Pascal, it is named after him because he studied the triangle and published the Traité du Triangle Arithmétique. And this is what he's also mainly known for, developing that book. Explanation of pattern and formula for the sum of the rows in Pascal's triangle. The first diagonal is just ones. As you can see at the top, it's just ones at the top. The second diagonal has counting numbers, such as 1, 2, and 3. As you can see, the second row of diagonals is 1, 2, 3, 4, 5, 6, 7. The third diagonal has triangular numbers. The third diagonal, as you can see, it goes 1, 3, 6, 10, 15, 21. The fourth diagonal has tetrahedral numbers, and it goes 1, 4, 10, 20, 35. The horizontal sums double each time. The formula for this would be 2 to the power of n. As you can see, if you were to put and go down the rows, it would go 1, 11, 121, which is 11 to the second power, and then 11 to the third power would be 1,331, and then 11 to the fourth power would be 14,641, and it continues to go up because that's the formula. Okay, now next. Explanation of pattern and formula for the sum of all elements. Formula. The sum of all elements of row k plus 1 is equal to 2 times the sum of the elements of row k. This means the sum of all the elements of row k plus 1 is equal to 2 times 2k. So if you were to plug in this formula, and plug in the numbers, you would be able to figure out the sum of all the elements. Okay, next. Oh, okay. Explanation of triangle numbers and how they relate to Pascal's triangle. Triangular numbers are any of the series of numbers 1, 3, 6, 10, 15, etc. obtained by continued summation of natural numbers such as 1, 2, 3, 4, 5, etc. The third row, the third diagonal, my bad, in Pascal's triangle is a set of triangular numbers. As you can see, the third row is 1, 3, 6. The third diagonal is 1, 3, 6, 10, 15, shown in the green. Okay, next. Uses and applications of Pascal's triangle. Pascal's triangle can show you how many ways heads and tails combine. This will then show you the probability of any combination. So by using Pascal's triangle, you'll be able to figure out the probability. If you toss a coin 3 times, there is only one combination that will give you 3 heads. But there are 3 that will give you 2 heads and 1 tail. There's also 3 that will give you 1 head and 2 tails. And 1 combination will give you all tails. This pattern is 1, 3, 1 in Pascal's triangle. Now if we go back and we look at the third row in Pascal's triangle, which is right here, third row is 1, 3, 3, 1, which is the same as the amount of combinations. Which is the same pattern that you will get when doing probability in heads and tails. So as you can see, it translates pretty simply from probability to Pascal's triangle. Lastly, these are the citations that I use for my research when finding information on Pascal's triangle. I found them very helpful and I didn't have any problems with the links that I came across. Well, that is the end of my video. I hope that I helped you with better understanding Pascal's triangle. And yeah, thank you.